Hello guys, we're back with another video of mathematics, and in this video I will show you how we can solve few of the questions that I have found out for you guys to practice along with me for the integration. So let's get started. So the question goes like that. So integration of tan square x dot dx. So this is the first question. Second question, I'm going to say integration of dx divided by sine square x plus sine square x cos square x. This is question number 2. All right, then the third question goes like integration of sine 6x, which is a power, plus cos power 6x divided by sine square x times cos square x. All right, so these are the three questions that we will be solving. So let's start with first answer number 1. So it says integration of tan square x dot dx. As we have seen in the last video, and also we know by identity that 1 plus tan square theta equals to secant square theta, right? Therefore, tan square theta equals to secant square theta minus 1. We are going to convert into this particular format because we know that tan square x or tan square theta, we don't have a direct application of integration on tan, so that's why we will convert in terms of secant square, because we know that integration of secant square theta is tan theta itself. So we can write this as equal to integration of, so instead of tan square I'm going to write secant square theta or secant square x minus 1 dot dx. It's the same exact thing, so I can further solve integration of secant square x dot dx minus integration of 1 dot dx. So integration of secant square x dot dx is tan x, alright, minus integration of dx, because 1 dot dx is same as integration of dx, is x plus the constant. So this is the answer. Similarly, answer number 2, I can write it down, is integration of dx divided by sine square x dot cos square x. So in this particular question, we need to think that what we can play with, because we know that sine square x dot cos square x, we have a couple of ways if we want to solve in UV, like integration of product rule, or if not, we also know that if there is nothing, then we can write as 1 dot dx, which is, we also know that sine square x plus cos square x equals to 1. So this is the identity that we are going to use. So I'm just going to use it here. So integration of, instead of 1, I'm going to put sine square x plus cos square x dot dx divided by sine square x dot cos square x, right? So this is going to be equal to, so if I break it down, so I can write as sine square x divided by sine square x dot cos square x dot dx plus integration of cos square x dot dx divided by sine square x dot cos square x, right? So we can see that sine square x and sine square x will cancel out. We are left with integration of 1 over cos square x is secant square x dot dx plus integration of cos square and cos square will get cancelled. 1 over sine square is going to be cosecant square x dot dx. Again, as we know, integration of secant square x is tan x plus integration of cosecant square x is negative cot. So I can simply override and cot x plus c. So this is the answer for question number 2. Similarly, if I move on to solve question number 3, alright, this is right here. I will be solving it right here, question number 3, which was if we see here, it says it's going to be integration of sine 6x, integration of sine 6x plus cos power 6x divided by sine square x dot cos square x. So dot dx, obviously. So this is slightly tricky. We know that we cannot play with any one of these until unless we have a definite purpose of using it. What I mean by that is either we can write it down separately, or what we can do is we know that sine 6x plus cos 6x, we don't have any identity that we can use. We know that we have sine square x plus cos square x, and that is equal to 1. This is all we know for now in terms of if we are trying to use identity. But what we can write is, we can also write it as sine 3x or sine cube x raised to power of 2 plus cos cube x raised to power of 2, right? So we can use this or similar to this format, or even better, there we go. This is what I'm going to do. Integration of sine square, I'm just going to write square x power 3 plus cos square x power 3 dot dx divided by sine square x dot cos square x. So let's see, a cube plus b cube. So we know that a plus b whole cube is equal to a cube plus b cube plus 3ab a plus b, right? So here if we compare this particular a cube plus b cube, we have that. So a plus b cube, I can subtract 3ab a plus b from it to get a cube plus b cube. So what's the next thing? I'm going to use this particular formula and substitute in that. I will get integration of a plus b whole cube, which will be sine square x plus cos square x whole cube minus 3a in this case is, so I can also write this as this particular thing as, oh, this is going to, yeah, this is going to be negative right here. So I can write this as 3a square b, and it's going to be minus sign and minus sign again. It's going to be 3ab square, right? Because we have a negative sign, we moved on the other side from right hand side to the left hand side. So minus 3ab, when I multiply commutative property and a square b and minus 3ab square, this is what we have. So it's going to be negative 3a square b. So a is sine, so sine square x square times b, and b is, we have cos square x, simple. And also subtract 3, a is sine square x times b square, which is cos square x whole square dot dx, and we are dividing the entire thing by sine square x dot cos square x. I know it got a little bit rushy. I'm just going to open it up here. So I have right now, so sine square x plus cos square x, we have the identity equal to 1. So I'm going to write 1 cube minus 3 sine power 4, so sine power 4x dot cos square x minus 3 sine square x, and I have cos power 4x dot dx again, but the entire thing is getting divided by sine square x dot cos square x dot dx. So I have 1 over sine square x dot cos square x dot dx minus integration of 3 sine 4x. So even if I want, I can take something common out from these two, because sine square x and cos square x is common. So I'm just going to take that, and also negative 3 is also common if we think about it. So I'm just going to write negative 3 outside, and I'm going to write this whole thing inside a bracket. So I'm going to write sine square x and cos square x as common. What I'm left with, so in this case, if I take common, I will be left with sine square x plus cos square x. There we go. Obviously dot dx, but I don't have space to write, so I'm just going to write it in that way. So this is going to be divided by sine square x dot cos square x. Alright, moving on to here. So I'm just going to copy what I wrote on that side. Integration of 1 over sine square x dot cos square x dot dx minus 3 integration of sine square x cos square x, and we have sine square x plus cos square x, that's going to be 1 dot dx divided by sine square x dot cos square x. So sine square x cos square x, we can cancel out the entire thing, it's common. So similarly, integration of 1 over so this we can solve in many different ways. Again, it's exactly the same thing as we started initially. You can see the first question that we had, or the second question, my bad, 1 over sine square x, you can solve in that sense as well. So we have 1 over sine square x dot cos square x dot dx minus 3 integration of dx is x plus c. So integration of this we have already solved in the previous question right here. If you're not sure, I can show you that integration of 1 over sine square x cos square x dot dx is tan x minus cot x. So I'm just going to substitute it, tan x plus tan x minus cot x minus 3x plus c. So that's our answer. Yep. So I hope you liked the way I solved this question. Thank you so much for watching, and do not forget to subscribe for upcoming videos. If you like it, share it with your friends. Take it easy. Bye.